Okay, plus 2. C. Yung na-capture ko ha, Agidilia. Iisang account yung gamit. So si Ayla lang yung may plus. Si Abrea.
Sir, ako din po!
Bakit? May sarili kang Zoom. Kung sino lang may hawak ng account. Para fair. Rocha, Padolina, Gonzales, Buloan, Estrada, Montalvo, Rain, then Alzaga. Yun lang. Yun yung may plus 2 sa midterm exam. Okay, okay. Game.
Aaron, huwag mo kami kainin.
Ha?
Kinakain po kami ng Aaron.
Sige, pwede kayo mag-dinner na. You can take your early dinner. Si Benzuela, hindi na natanggal ang ngiti.
Sir,
Si
yung kinakain po
OA.
namin,
Baka
sir.
sir, pwede pang humabol.
Wala na, huli ka na.
Kahit
Okay.
sir hanggang pagkatapos ng klase, nakaganto ako.
Go! Push mo yan. Eh, share screen. Wala naman. Okay. Hindi ko pa din na-edit. Okay. So, this will be the last topics for your midterm examination. So again, your midterm examination will be on November 24, 7:30 to 9 a.m. Okay? Okay. So to start, so line source coding, or in some books, you can read that as line coding or line source coding. Okay? So ginawa ko lang siyang line source encoding. So basically, when we talked about line source encoding, so that is a process or a process wherein digital data in the form of binary coded sequence is transform into binary signal. So, paano yun? So, basically, sige, stop sharing ko lang siya. So, when we're dealing with line source encoding or line coding, so this binary data in the form of binary coded sequence 101 0011. So, this is an example of binary coded sequence will be transformed into a digital signal. So ang tawag po dyan ay line source coding, line source encoding. Okay? So in line source encoding, so there are different types or methods on how you can transform a digital coded sequence into a binary signal. So first of which is using the unipolar method. Okay, so when we're dealing with unipolar method, so unipolar encoding is unipolar encoding is single non-zero voltage level and zero voltage level are used. So it is primary and very simple coding. Okay, so in other words, so when using unipolar coding or encoding, so we only have two values. First of which is the zero voltage amplitude and the non-zero voltage level or the 1, 1, 0. Okay? So, paano yon? So, there are examples under line source encoding. Snip lang ako. Ano ba yan? In-snip ko lang po. Nag-snip lang ako while teaching file. Save, save as 11, 16, 20, 23. Gutom na ako. Okay, so under unipolar, so we have the unipolar non-return to zero signal encoding or the uni-NRZ. So when the data bit is 1, the width and the gap between bits of unipolar non-return to zero are equal to each other. Mali, to each other. When the data bit is 0, then the pulse is represented as 0 bit. Okay, so as you can see, it is represented by X and Y axis. Okay, and with the amplitude A and 0 voltage. Okay, so as you can see, when we're dealing with unipolar, so we only have two values. Okay, first of which is the positive voltage level and the 0 level. Okay, 0 and positive voltage level. Okay, so paano siya i-graph? Ang sabi, kapag daw nag-graph tayo ng unipolar non-return to zero, ang height ng 1 ay positive voltage level 1. So kapag 0, di 0. Kapag 1, diretso lang. Kapag 1, diretso lang. Okay? Then kapag 0, 0 siya. Ganun siya. So other example, for example, meron tayong 1, 1, 0, 1, 1, 0. So 1, 1, 1, 0, 1, 1, 0. Okay? So, ganyan po mag-graph ng unipolar non-return to zero. Nagets po ba?
Yes po.
Question, clarification. So, kung walang question or clarification, we can move on. Okay. Sa next naman is unipolar return to zero signal encoding. So, that is uni-RZ. So when the data bit is 1, the signal amplitude at 1/2 bit time is positive voltage level, and the rest of the bit time is represented as 0 voltage. When data bit is 0, there is no pulse wave. That means the single amplitude is 0 voltage. Okay? So basically, when we're dealing with unipolar na return to 0, okay, sa pag-graph niya, lahat ng makikita mong 1 ay merong height na half na positive voltage level. Half. So, lahat ng 1, graph natin, ay, ano ba yun? Half lang. Okay? Lahat ng 1, half lang. Then, kapag 0, automatic, 0 ang kanyang amplitude. Yan, ganyan siya. So, halimbawa, example pa. So, 0, 1, 1, 0, 1. Okay? Okay? Kalahati lamang. So, kapag 0, okay lang, kalahati. Kapag 1, kalahati. So, unahin lahat natin ang lahat ng 1. Then, saka natin idiretso. Okay? Nakuha kung paano i-convert yung digital data into digital signal.
Yes po.
Okay. So that is for unipolar return to zero. Next. So previously we discussed unipolar. So now we have bipolar. Okay. So when we're dealing with bipolar, so the difference between unipolar and bipolar is that in unipolar, we only have 2 voltage level. First is the positive and the 0 level. While in bipolar, we have 3 voltage levels. First is the positive, negative, then the 0. Okay? So 0 is for 0 voltage and for 1 represents alternating positive and negative voltage. Okay? So paano daw siya? So ganito lang siya. Okay? So under bipolar, meron tayo ding bipolar non-return to zero signal encoding or BIP NRZ. So when the data bit NRZ is 1 or 0, the signal amplitude will be a positive or a negative voltage level. As for bit time, no matter the data bit is 0 or 1 or 0, the voltage level remains the same. Okay, basic. So ibig sabihin, lahat ng nakikita mong 1, ang kanyang amplitude ay positive voltage level. Okay? Lahat ng 1, nakikita natin, positive voltage level. At lahat ng 0, negative. Okay? So, maglagay tayo ng negative. Ganyan lang siya. Okay? So, other example, pwedeng 0, 1, 1, 0, 1, 0, 1. So, ito. So, yung gagraph natin, so this will be 0, 1, 1, 0, 1, 1. Okay? Nagets po kung paano i-graph yung BIP NRZ?
Yes.
Po.
Question. Question po. Nakakasabay pa?
Yes po.
Okay. Okay. Next. Yan. So kung meron tayong unipolar RZ, meron tayong bipolar return to zero signal encoding. So when the data bit is 1, the signal amplitude at 1/2 bit time is positive voltage level and the other half bit time is negative voltage level. When the data bit is 0, the signal amplitude of the bit time is represented as negative voltage level. Okay? So kung nakikita nyo, katulad din siya ng unipolar na lahat lamang ng 1 ang may height. Okay? Kalahati. Laging kalahati ulit. Lahat ng 1, kalahati. Okay. Then lahat ng 0 ay negative voltage level. 0, negative. Lahat ito 0. Yun. Okay? Nagets?
Po.
Okay. Fifth example. So Manchester signal is also known as split phase signal. So when the data bit is 1, the signal amplitude at first bit time is positive voltage level and the other 1/2 bit time is negative voltage level. When the data bit is 0, the signal amplitude at first 1/2 bit time is negative voltage level and the other 1/2 bit time is positive voltage level. Okay, so kapag Manchester, ganito naman. Kung nakikita nyo, kapag Manchester, wala siyang negative amplitude. Okay? We only have the positive voltage level and the 0 voltage level. Okay? So, tingnan natin, lahat ng 1 na makikita mo ay may height na kalahati ng nasa left side. Okay, puntahan muna natin. Lahat ng 1 nasa left side. 1 left side. Okay, then lahat daw ng 0 nasa right side. Okay, then saka po natin i-connect. Okay? Okay. Nagets po?
Yes po, sir.
Okay, clear. Okay. For the last encoding, which is the alternate mark inversion signal encoding or AMI, it is just similar to RZ except that the alternate I are inverted or the alternate 1 are inverted. When the data bit is 1, the first signal amplitude at 1/2 bit time is positive voltage level. Ibig sabihin, kalahati lang ulit. And the other half time bit time is 0 voltage. Then, the second signal amplitude at 1/2 bit time is negative voltage level, and the other 1/2 bit time is 0 voltage. Therefore, the only difference between AMI and return to 0 is the alternate one are inverted. Then, the data bit 0, the signal amplitude is 0 volt. Okay? So, sa madaling sabi, kapag AMI, meron tayong alternating positive and negative voltage levels. Kapag 0, automatic, walang height. Okay? Walang amplitude. Flat lang. Okay? So, ibig sabihin, kalahati lang din to. So, dahil ito ay 1, positive muna siya. Ano ba yan? Then, dahil siya ay 1, positive sa taas, then kapag may kasunod na 1, so negative naman siya sa baba. Then, meron ulit 1, sa taas ulit siya. Then, the rest, 0. Okay? So, halimbawa, ganito. 1, 1, 1, 0, 1, 1, 0. Okay? So, halimbawa, kung igagraph natin yan, so, kalahati. So, meron tayo dito. Then, kalahati, meron tayo dito. Alternate, 1 ulit, kalahati. O dahil 0 siya, wala. Alternate sa baba. Alternate sa taas. Then, connect natin. Nagigets?
Po.
Gets po ba ang AMI?
Yes po.
Yes.
Yes po, sir.
Okay. 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 Okay, next na. Ayan. Next natin will be line encoding bit rates. Okay? So, of course, when transmitting or converting those binary coded sequence into digital signal, there is, syempre, it consumes time. Okay? So, gaano kabilis? Yung pag-transfer or pag-convert ng binary coded sequence or binary data into digital signal. Okay? So, that is called line encoding bitrate. So, the bitrate of an encoding technique depends on the shortest period of time to make a transition from high to low. So, it can be succeeding ones kasi pwede siyang 1, 1, 1, 1, 1, 1, okay? Or succeeding zeros or 0, 0, 0, 0, 0, or alternating 1 and 0. So, it can be 1, 0, 1, 0, 1, 0. Okay? So, yun yung ibig sabihin nun. So, again, we have different formulas for us to find the bitrate of each coding techniques. Okay? Remember that we only have two formulas. Okay? So, that is 1 over 2 delta T over delta TL or 1 over delta TL. Okay? So, when using unipolar return to 0 and Manchester, so that is UPRZM, tandaan nyo, UPRZM, ang gamit lang natin doon ay 1 over delta TL. Okay? So the rest, ang gamit na natin ay 1 over 2 delta TL. Okay? So FB is the bit rate. Delta T is the pulse spreading constant, which is in nanosecond per kilometer. And L is the cable length. Okay? So always remember that when using this formula for bitrate, the units should be of the same value. Okay? So kung kilometer siya, kilometer yung length. Kung meter siya, meter yung delta T, dapat meter din yung L. Okay? So dapat parehas po sila. Okay? Okay, solve po tayo. Given the pulse spreading constant equal to 20 nanosecond per meter and the cable length equal to 100 meters, determine the maximum bit rate in BPS, in Mbps in bipolar return to zero transmission. Okay? So as you can see, we are asked to compute for the bit rate, but in terms of megabits per second using the bipolar return to zero transmission. Okay? So isolve po natin. Okay. So first question, given R, so we have the pulse spreading constant, that is delta T, which is equal to 20 nanosecond per meter, which is equal to 20 times 10 raised to negative 9 second per meter. Okay? And length, or the cable length, which is equal to 100 meter. Okay? Again, so that is not UPRZM. So what we're going to do is find bit rate using 1 over 2 delta TL. Okay? So this is just direct substitution. So this will be equal to 1 over 2 delta T is 20 times 10 raised to negative 9 second per meter times 100 meters, which is equal to, paki-compute po,
So, 250. Ay, 2.5.
that is 250,000 nga ba?
1,000. Yes po.
So, lumabas po ay 250,000 BPS. Okay? Yet, we are asked to find the bit rate in terms of Mbps. So, what we're going to do is 250,000, sorry, that is too much, BPS, okay, times ang ating 1 Mbps is equal to 1 million BPS. Okay? So, ang sagot po ay this will be cancelled. Ano po sagot?
0.25 po.
So, the answer is 0.25 Mbps. Okay? Okay. Clear. Is it clear?
Crystal clear.
Okay. Taray, crystal clear. Okay. So, we solve another question. So, basically, the second question has same given, yet we're asked to find the maximum bit rate in terms of Manchester transmission. Okay? So by using the same given, we are going to solve the problem using Manchester transmission. Okay, so same given, yet the formula to be used is 1 over delta TL. Okay? So sabi ko, kapag Manchester at unipolar RZ, you're going to use 1 over delta TL. Delta TL. So that is 1 over 20 times 10 raised to negative 9s over m times 100 meters. So ano sagot?
0.5.
So this will be equal to 0.5 Mbps. Okay? Yun. So yun po. So that is how to find the bit rate Okay. So after finding the bit rate of different line encoding techniques, so we're going to move on to quantization. Yawn. So, have you heard quantization?
Yun pa lang po.
Okay. So quantization is the process of mapping continuous infinite values to a smaller set of discrete finite or finite values. So the method of sampling chooses a few points on the analog signal, and then these points are joined to round off the value to a near stabilized value. Such a process is called quantization. So parang ang vague or medyo mahirap intindihin. So bigyan ko yun ng example. So, i-visualize nyo lang to. That is quantization. Then, explain ko. Okay? So, nakita nyo yan. So, drawing ko ulit. Ay, nako. COA. COA. Okay. So basically, when we're dealing with quantization, so it starts with an analog signal. Okay. So in digital signal processing, so maririnig niyo yung word na continuous, okay? So it deals with analog systems, okay? So pag umabot kayo ng fourth year, so, meron tayong tinatawag na digital signal processing. Okay? So, tinitik yun ng fourth year. And supposedly ako nga yung nagtuturo nun, kaso nga lang wala magturo nitong data comms na to, digital comms na to. So, kaya ako napapunta sa third year. Heist. Okay? Then, so, using this analog signal, so we're going to get samples. Okay? So, yan. So, this is called sampling. Okay? This is where you get samples from the analog signal. Okay? Then, yung magiging output niyan, ang tawag po doon ay quantized signal. Okay? So itong quantized signal na to, meron siyang equivalent binary coded sequence. So it can be 1100, 0011, 1011, 0 whatsoever. Then ito ay mako-convert into digital signal. Okay? So yan yung kino-convert nating digital signal. Okay? So that is in terms of signal. Okay? So, paano naman siya in terms of numbers? Okay? So, basically, when we're dealing with quantization, basically, we are rounding off. Okay? So, familiar naman kayo. For example, you are given an analog signal of 5 volts. Sorry. 5.03 volts. Okay? Then, dahil sa quantization, inera-round up natin siya into a whole number. So, this will be equal to 5 volts. Okay? So, dahil siya ay decimal, so what we're going to do if you are asked again, sige, clear ko lang para walang, so yung 5.03 volts, ginawa nating 5 volts. Okay? So, yung 5 volts, pwede natin siyang i-convert into 12-bit code. Okay? So, if you are asked to find the value of the 12-bit code of 5 volts, so pakipindot. Yung 5 volts gawin nating binary. Convert 5 into binary. Ano sagot?
Ano pong 8 tapos po 0101.
Okay? 101 ang huli?
Yes po.
Okay. So, start tayo sa 101. Then, dahil sinabi 12-bit, di bumilang tayo. So, this will be 3. So, 8, 0, 3, 4, 5, 6, 7, 8. So, 1, 2, 3, 4, 5, 6, 7, 8. So, 11 pa lang yan. So, ang sabi, 12-bit. So, dahil siya ay positive, sa communications, kapag positive, maglalagay ka ng 1. So, this is your sign bit. Okay? So, tama, sa LX nga ba, sa logic circuits, ang 1 ay negative bit.
Opo, sir. Negative po.
Okay. So, sa communication, so that is positive. Okay? Kasi kapag magagraph tayo, that is 1, 0. Okay? So, pag i-convert mo daw pala ito, so this will be equal to 1, tapos 1, 2, 3, 4, 5, 6, 7, 8, 1, 0, 1. Okay? So, pumapasok yung quantization dyan kapag ni-round off natin yung 5.03. Okay? Then, magkakaroon ng quantization error due to rounding of values. Okay? So, yun siya. Is it clear?
Star clear.
Any clarification, question, confusion? Okay. So, if wala, we can move on. Okay. So, yun yung binabanggit ko kanina, ang quantization error. So, quantization error, it is also known as quantization noise. Why? Because as you can see, noise adds error. Okay? So, mamaya makikita nyo how noise adds error in terms of amplitude. So, in terms of quantization, nagiging error siya or noise siya kasi because of rounding of values. Yung example ko nga, nagkakaroon ng error between 5.03 and 5 volts because of rounding the values. Okay? It is the inaccuracy caused by the representation of continuously varying quantity as one of a number of discrete values or discrete values. It is also equivalent to additive white noise as it alters the signal amplitude. Okay? So basically, when there is a noise, so for example, so, sa digital signal, okay, so ang representation po ng amplitude ay ganito. Yan. So, that is, kapag digital, so that is x of n. Kapag po analog or continuous, ito po ay x of t. Okay? So, x of t and x of n. Doon sa digital signal processing, matututunan nyo yan. Okay? So, to be able to find the quantization error, so what you're going to do is divide the resolution by 2. Okay? So, meron tayong resolution. So, always remember that the maximum quantization error or the quantization error and resolution are in terms of voltage. Okay? Okay. So, resolution naman. So, resolution is the magnitude of the quantum. Ano yun? May nag-chat. Quantum is the magnitude difference between adjacent steps, also known as quantization interval. So it is the smallest possible magnitude that can be decoded by the DAC or the digital to analog converter. It is equal to the voltage of the minimum voltage. Okay? So always remember that when we're dealing with resolution, okay? So that is always equal to the minimum voltage given. Okay? So yun lang yung kailangan nyo tandaan. So that is that the resolution is equal to minimum voltage. Okay? So mamaya magagamit natin yung mga formulas. Okay. So next term is the dynamic range. So dynamic range is basically the ratio of the largest possible magnitude to the smallest possible magnitude other than 0. Okay, so when we're dealing with dynamic range, we're not dealing with 0 voltage. Why? Because when you divide any number by 0, so that will be undefined. Okay? Okay. So, kaya dapat laging greater than 0. Okay? So, sabi daw, ang dynamic range ay equal daw kay maximum voltage over minimum voltage. Okay? Kanina, napag-aralan natin na ang Vmin pala ay equal kay resolution. So, ang dynamic range din pala ay pwedeng makuha kapag may giving resolution. Kasi ang resolution daw po ay equal kay Vmin. So, dynamic range is equal to Vmax over resolution. Okay? Then, if we are going to find the decibel value of the dynamic range, so what you're going to do is just find the 20 log of Vmax over resolution or 20 log ng Vmax over Vmin. Okay? So kapag hindi given ang resolution, so anong given ay Vmin, hindi yan ang gagamitin natin. Okay? So 20 log Vmax over Vmin. Okay. So try natin mag-solve. So for a PCM or pulse code modulation, so hindi ko na diniscuss yung mga pulse width, pulse code, okay? So basically yun din yung line source coding, okay? So for a pulse code modulation system with the following parameters, determine the quantization error. So maximum analog input frequency is 4 kHz. The maximum decoded voltage at the receiver is positive and negative 2.55 volts. And the minimum dynamic range is 48 decibel. Okay. So, dahil ang given natin ay in terms of decibel, edi gamitin natin yung formula in terms of decibel. So, that is dynamic range, dB, is equal to 20 log Vmax over resolution. Okay? So, substitute lang po natin yung given. So, dynamic range is equal to 48 is equal to 20 log. Anong ating Vmax? As you can see, we have positive and negative values. So, that is positive 255 and negative 255. So, when we're dealing with Vmax, we need to use only the positive value. Okay? So, this will be equal to 2.55 V over resolution. Okay? So, ano pong value ng resolution natin?
.5 po ba, sir?
Mali. Resolution.
1.0625 po ba?
Ha? Pipindot na lang, mali pa?
0.01 po.
Ano sagot?
0.01.
Okay, so that is 0.01 V. Okay, so kanina, ang tanong ay quantization error. So sabi, ang quantization error daw ay equal kay resolution divide 2. So ang sagot ay 0.005 V. Okay? So that is the quantization error. Okay? Nagets po ba? Any question, clarification? Okay, so kung wala, we can move on. Gutom na mi. Gutom na mi. Okay, next slide. Ayan. For linear sine magnitude PCM. Ay, hindi pa. Meron pa ata. Okay, ito pala. So, for linear sine magnitude pulse code modulation, we can also find the dynamic range. So, to be able to find the dynamic range, so that is 2 raised to n minus 1. And if we're going to find the decibel value, lagi lang tayo magkakaroon ng 20 log 2 raised to n minus 1. Okay? So, always remember when asked to find the value of n, so ang mahahanap nyo lang doon po ay magnitude bits. That excludes the sine bit. So, ano ba yung sinasabi ko ngayon? So, halimbawa, meron tayong 1, 0, 1, 0, 1, 1, 1. Okay? So, 1, 2, 3, 4, 5, 6, 7. So, this is a 7-bit linear sine magnitude PCM code. Okay? This is 7-bit. Kasi, yung first bit po ay sine bit. Okay? So, lagi po, when computing for the dynamic range ng linear sign magnitude PCM code, hindi po natin isinasama ang sign bit. Only the magnitude bits. Okay? So, all the numbers following the sign bit is called the magnitude bits. Okay? Nakukuha po ba?
Yes po.
Okay. Solve na natin. So, determine the resolution of an 8-bit linear sign magnitude PCM for a magnitude decoded voltage of 2.55 peak voltage. Okay. So, kanina, we found out that dynamic range is equal to Vmax over Vmin or the resolution. And we can find the dynamic range of linear sign magnitude PCM equals to 2 raised to n minus 1. Okay? So using these formulas, we can equate both the values of dynamic range. So this will be equal to Vmax over resolution, which is equal to 2 raised to n minus 1. Okay? So we are asked to find the resolution. So Vmax is equal to 2.55 divide resolution is equal to 2 raised to n. Again, when getting the values of n in a linear sign magnitude PCM, we exclude the sign bit. Okay? So dito, meron pa siyang sign bit. So this will be equal to 8 minus 1. So this will be equal to 2 raised to 7 minus 1. So the resolution is, pakisolve po.
127.
Ha?
27 po.
Hindi.
0.02 po.
So the answer is 0.02 volt. Okay? So 2 raised to 7 yun na.
Ako, sir.
Okay? Chip solve. Okay? Okay. Okay, next. Problem solving ulit. Next is, what is the dynamic range in dB of an 8-bit linear sign magnitude PCM whose PCM spectrum whose maximum decoded voltage at the receiver is 1.27 peak voltage. Okay? So we are asked to find the dynamic range in dB. So this is just direct substitution. So direct dynamic range dB is equal to 20 log 2 raised to n minus 1 or 20 log 2 raised to 7 minus 1. So your answer is
42.07.
mali. Ano ba't mali-mali ang pindot mo? Marunong ka ba mag-calcu?
Ako ulit, sir.
Ha?
Ganun pa, no? Po talaga sir yung lumalabas sa 20 log 2 raised to 7 minus 1.
20 log. Ano sagot? Ano sagot mo?
42.08.
Okay. So, 2 decimal places. So, this will be equal to 42.08. Don't forget dB. Okay? Kasi siya ay naka-dB. Okay? Okay. Moving on. Okay, gets na po? clarification, question? Okay, kung wala, move on tayo. Okay, so for linear PCM code, iba ang formula naman kapag linear PCM code. Okay? So, linear PCM code, so that is 1.76 plus 6.2 n. Okay, so when dealing with linear PCM code, so dun ang value po ng n ay number of magnitude bits. Okay? So ano naman kapag linear PCM? So kung halimbawa meron tayong 10, 10, 11, 11 whatsoever, ang tawag po dyan lahat na yan ay magnitude bits. Okay? Wala po siyang sign bit. Okay? Kapag linear PCM code. Okay? We don't have a sign bit. Okay. So solve natin. So find the maximum dynamic range for a linear PCM system using 12-bit quantizing. So gamitin natin yung formula. So that is dynamic range dB is equal to 1.76 plus 6.02n. So this will be equal to 1.76 plus 6.02. Again, all this 12-bit is considered as the magnitude bit. So times 12. So ano pa ang sagot?
74.
74.
So this will be equal to 74 decibel. Okay? So ganun lang siya. Okay, wag malilito, wag malilito. Okay, next. Itong signal to quantization noise error, sige, hindi ko na isasama. Kasi masyado siyang madami pa din. Okay. Okay, coding na tayo. So coding, it is the process wherein the quantized intervals assigned to the individual pulse amplitude modulation, so that is PAM, are converted into binary signals. So that is, coding is the conversion of sampled analog signals into a pulse code modulation bit stream, and decoding is the conversion of a pulse code modulation bit stream to analog samples. Okay? So basically, when we code, so in terms of, aray ko. Sige. So ganito siya. So, 'di ba? Sa coding kasi 101100. So, ito yung quantized signal. Okay? And then each signal or each sample ay meron siyang representation ng binary coded sequence. Okay? So, ang tawag po doon ay coding. Tapos, kapag kinonvert na ito into binary signals, so, doon papasok yung coding. Okay? So, paano ginagamit yung coding? So, ginagamit yung coding in terms of coding efficiency. So, halimbawa, ganito. Ay, nasa next slides pala yung coding efficiency. So ito muna. Coding efficiency, it is a numerical indication of how efficiently a pulse code modulation code is utilized, and it is defined as the ratio of the minimum number of bits required to achieve a certain dynamic range to the actual PCM bits used. Okay. So ano ibig sabihin ng coding efficiency? Halimbawa daw, meron tayong PCM code, quantized code. So halimbawa, pag binilang natin siya, so hindi siya exact, okay? So pwede nating sabihin na halimbawa ay 1 2 3 4. So hindi siya magkakatulad ng amplitude, 'di ba? So pwede nating sabihin na 8.76 for example. Okay? So using coding efficiency, pwede natin siyang i-round off into its maximum or the actual bit. So wala naman talagang 0.76 bits, di ba? So dapat laging whole number. So it can be 9. Okay? Then, doon natin malalaman how efficient the modulation is. Kasi, wait lang, paano ba to? Tingin ko magbigay ako ng example. Problem solving para mas magets niyo. So anyway, ganun yung concept ha. So hindi laging exact yung pagkaka-convert ng digital signal into digital data. Okay? So yung point niya, so yung 0.76, wala naman talagang in real life wala namang 0.76 bit. Okay? So siya ay ira-round off or round up. Pero laging round up. Okay? Lagi tayong round up. Okay? So parang ganito, in terms of, ito yung in terms of rounding ha. So sa tao, wala namang, halimbawa, tinanong sa inyo yung population na nagkaroon ng 0.12. Okay? Wala namang 0.12 na tao. Okay? So lagi siyang round up. Ganun yung concept niya. Okay? Hindi naman. Gugutom na ako. Nagugutom na kayo?
Yes po.
Opo.
Gutom na din ako. Grabe. Grabe yung gutom ko. Okay. Ayun. So sige, mag-solve tayo. So a PCM system has the following parameters. So a maximum analog input frequency 4 kHz. Okay, so basically, pareha siya nung example kanina. Kaso ang hinahanap dito ay coding efficiency. Okay? So coding efficiency. So always remember na kapag hindi sinabi yung linear PCM or linear sign, ang ating gagamitin lagi ay linear sign magnitude PCM. Okay? So ang default po natin ay linear sign magnitude PCM. Okay? So dahil siya ay naka-decibel, so gamitin natin yung decibel value niya. So that is dynamic range dB is equal to 20 log, ano ngayon, 2 raised to n minus 1. Okay? Okay. So, dynamic range na ay 48 is equal to 20 log 2 raised to n minus 1. Okay? So, anong po ang value ng 1? Ang value ng n?
Seven point 98.
Okay. So, the value of n is 7.98 bits. Okay? So, remember na when we're solving linear sign magnitude PCM, di ba, ito ay ini-exclude niya yung sign bit. Eh di magpa-plus pa tayo ng 1 bit para i-include yung sign bit. So, this will be equal to 8.98 bits. Okay? So, sa coding efficiency, so what is the minimum? 8.98 bits. Then, the actual, kasi wala namang 0.98, so gawin natin 9 bits. So, times natin ang 100. So, that will be your coding efficiency. So, anong coding efficiency?
Um, 99.7.
Decimal places?
99.77.
78.
78.
So, the coding efficiency is 99.78. So, near perfect yung pagkaka-convert during coding. Okay? So, nagets po ba yung coding efficiency? Clear? Hello? Nawawala na kayo?
Yes po.
Clear po, sir.
Okay, so ano na to? Konti na lang to. Last 6 slides. Ito, last topic na tong compounding. Okay? So, compounding, it is the process of compression. So, basically, when we're dealing with compounding, so that is compressing, then expansion. Okay? So, it is used to protect the lower amplitude signals from noise. So, sige, explain ko yung compounding. Stop share. So, ganito siya. In digital signal, napiyok pa. In digital signal, so halimbawa, meron tayong, amplitudes. So, these are discrete amplitudes. So, this is x of n. So, this is n. So, ganyan po ang representation ng digital amplitude sa digital signal processing. So, halimbawa, yan yung amplitude niya. So, ang ginagawa ng compounding is that it protects the lower amplitude, okay, from noise. Okay, so, paano yon? So, di ba, halimbawa, ang noise natin, yan yung noise natin. Okay? So, kapag yung mga lower amplitudes, natamaan ng noise, nagkakaroon ng error, causing to eliminate the lower amplitudes. Okay? So, bumababa lalo yung mga amplitude kapag meron tayong noise. Okay? So, ganun siya. So, ang ginagawa ng compounding, iniiwasan niyang mangyari yon. Okay? So, it prevents the lower amplitude signal from noise. Okay? So, meron tayong different types ng compounding. So, we have the analog and digital compounding. Okay? So, kapag sa analog, so, nag-occur siya kapag kino-convert natin, nag-occur siya, the compounding process occurs before converting the signal into digital form. Okay? So, digital signal, so nag-occur siya after converting the signal into digital form. Okay? So, analog signal, ito yung mga ginagamit basically. So, ang basa po dito ay mu law. Ganito kasi talaga yan. Mu law compounding. So, ang gumagamit niyan ay United States of America and Japan. So, US and Japan. Yung A law, ang gumagamit niyan ay yung mga European countries. Okay? So, paano siya? So, mu law. So, sa mu law compounding, meron tayo, to be able to compute, so, ang mini-measure po sa mu law ay output voltage. Okay? So, the formula is output voltage is equal to maximum voltage multiplied by the ln of 1 plus compression factor multiplied by Vin over Vmax over ln of 1 plus compression factor. Okay, so when we're dealing with mu law compounding, kapag hindi po given ang compression factor, ang ginagamit po nating value ng mu ay 255. Okay? Always remember that in mu law compounding, whenever the compression factor is not given, we're going to use the value 255. Okay? Okay. So mag-solve tayo. So assuming maximum voltage of 1 volt, what is the output voltage of mu law compressor if the input voltage is 0.2 volt? So given po natin is a Vmax 1 volt, Vin is equal to 0.2 volt. Okay, solve po natin Vout is equal to Vmax multiplied by, ano ang formula? Ln nalimutan ko din. Okay, so this will be Ln ng one plus mu Vin over Vmax over 1 Ln ng 1 plus mu. Okay? Substitute lang natin. So, Vout is equal to 1 multiplied by Ln ng 1 plus 255 multiplied by 0.2 over 1 over Ln ng 1 plus 255. Okay? So, ang sagot po, kung pipindutin niya ay 0.713 volt or 0.71 volt. Yun. Okay, na-gets kung paano mag-compute ng mu law compounding? So, lagi ang given dyan ay input and output voltage and maximum voltage. Okay? Next. Last na.
Pwede
So,
po pa ulit.
Okay.
Yun po. Okay na po.
Okay? So, last topic is the A-law compounding. So, again, same lang siya. Kaso mo nga lang, kapag A-law compounding, if the compression factor is not given, what you're going to do is to use 87.6. Okay? 87.6. So, the formula is V out is equal to V max multiplied by A or compression factor multiplied by Vn over Vmax plus 1 plus LNA for Vn over Vmax is greater than 0 but less than 1 over A. Kapag naman Vn over Vmax is greater than or equal to 1 over A but less than 1, so ang formula po ay Vmax multiplied by 1 plus Ln ng AV and Vmax over 1 plus LNA. Okay? So dito, kailangan natin first in solving A-law compounding, first we need to test the value of Vn over Vmax. Kung saan siya papasok. Okay? So halimbawa, isolve po natin yung number, yung given kanina using what? A-law compounding. Okay? So una, itest natin yung value ng Vn over Vmax. So, ang Vin po natin ay 0.2. Ang Vmax po natin ay 1. So, that is 0.2. Okay? So, ipasok po ba siya sa case 1?
Yes po.
Hindi. Siya ay sa case 2. So, ang case 1 po ay 0, 0.2, but less than or equal to 1 over A o 1 over 87.6. So, 0, 0.02, 0.01. So, ang 0.2 ba ay greater than 0? Yes. Correct. But less than 0.01? Wrong. Okay? So, sa case 2, ang 0.02 ba ay greater or equal to 0.01 but less than or equal to 1? Correct. So, ang 0.02 po ay greater than 0.01 pero less than 1. So, ang gagamitin po nating formula ay yung formula number 2 or yung case 2. So, which is equal to V out is equal to V max multiplied by 1 plus Ln ng A V in over V max over 1 plus LNA. Okay? So, ilagay nyo lang yung mga values. Ang magiging sagot po ay 0.706 volt. Kaya na po mag-compute or 0.71 V. Okay? So that ends your midterm. Mati na ako, gutom na ako. So isesend ko naman siya, siguro bukas na may gagawin lang ako, i-convert ko pa siya. So bukas, i-convert ko yung, sige mamaya, may gagawin ako. So, ipasa ko sa inyo yung PowerPoint presentation. Okay? So, any more question, clarification, confusion? Wala na? Okay. So, bye-bye. Thank you so much.
Thank you po, sir.
Thank you po,
Okay.
sir.
Hello, sir!
Thank you.